change out this bad DC to DC converter. And then we're going to test the input hybrid modules. There's a new DC to DC converter. Solder there. Help that old solder flow up into the solder sucker. Fell right out. Right bad on here so I don't get it mixed up with the good ones. There we go. Got a new DC to DC converter installed. Let's power it up. Look at the output with the soap. Now let's take a look at the 5 volts. Oh yeah, that's good. That's good. We have a good clean 5 volts. Here we are at 5 volts per division, and right now, let me get it closer to ground. Oh, just a skoshie bit, there we are. Now we're sitting at ground. We're going to look at the 5 volts. Hey, that's good. That's good. It's not dropping out anymore like it was before with that bad DC to DC converter. We got a good clean 5 volts. Good morning all. Now that we have a good 5 volts on the logic by replacing this DC to DC converter, we can test the input hybrid modules. I'm only going to go through one connector so I don't bore you by going through all 4 of these input connectors. I've got 2 24 volt DC power supplies right here. One to power up the logic and the other to probe the input, to activate the input to the hybrid module. Now we're going to use our multimeter to determine whether the output is on or off when we flag this input. Right here on pin 12 of each connector is ground back to the 24 volt DC power supply. Here's plus 24 volt DC that we're going to apply to each input. And when we do that, this LED will come on representing that I've made this input. And we're going to look at the output side of the optocouplers in that hybrid module with the multimeter. I've got ground of my meter connected to one end of this axial electrolytic capacitor, which is tied to ground of the logic circuit. Let's get a little bit closer and we'll start the test of these two input hybrid modules. The first thing I like to do is go through and tag all the inputs and make sure that the LED turns on. If the LED doesn't turn on, we've got a problem in that circuit. At the end of the video, I'll go over my drawings of this circuit so that you can test your OsaiRing input hybrid modules. Now let me grab my red lead, and we're going to go to pin 9, which is output number 1. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see we're turned off. And when I flag this first input, that output side of the optocoupler goes to 5.08 volts, 5 volts. Let's do that a couple of times. Now we go to pin 2 on the connector, and we go to pin 10 on the hybrid module. And we do the same thing. Pin 11 on the hybrid module, pin 3 on the connector, that circuit's good. We go to the next pin on the hybrid module, that's pin 12. We go to pin 4 on the connector, on, off, on, off. Now we go to pin 13 on the hybrid module, pin 5 on the connector, on, off, on, off. That circuit's good. Now pin 14 on the hybrid module, this is the last output on that hybrid module. 2, 3, 4, 5, 6 on the connector. We're on. We have good 5 volts on the output side of the optocoupler. Off, on, off, on, off. Now the next 6 pins on our connector go to this hybrid module in the back. I don't know if you're going to be able to see me get on the pin, but I'm going to get on pin 9 there. We're going to go to pin 7 here. 1, 2, 3, 4, 5, 6, 7. There we are. Off, on, off, on, off. Okay, I'm going to pin 10, on, off, on, off. That's pin 10 on the hybrid module, pin 8 on this connector. Okay, here's pin 11. Pin 9 on the connector. That's a good circuit. Okay. is 12 on the hybrid module. And 10 on the connector. Now the last one, here's 13. And this is pin 11 on the connector, pin 13 on the hybrid module. On, off, on, off. That's good. Now on the backside hybrid module, we didn't use that last input optocoupler. We used 6 on the first. That's 1, 2, 3, 4, 5, 6. And 5 on the backside. 7, 8, 9, 10, 11. The 12th pin on this connector being ground back to the 24 volt DC power supply. There you go, folks. Wasn't that a lot of fun? You got to see how to test your input hybrid modules on the OsaiRing. Now, we'll go over the paperwork when we get back to the house. Got a little bit of work to do here yet before we get there, so it'll take a little while. We'll see you then. Evening all. Let's talk about the input hybrid module and the external circuitry of that hybrid module. Now, inside this box right here is what I believe to be the circuit. I cannot be sure because this hybrid module has a coating on the outside that covers everything up. But from the function that we see, this circuit right here makes sense. Now here's my probe, my plus 24 volt DC probe that I use to activate the inputs to that circuit. Here's the protection diode going back to ground. Here's the green LED on the front of the OsaiRing. Over here is the output of the hybrid module that we looked at with our digital multimeter. Now let's see what's going on here. First, let's say we do not apply 24 volts DC to that input. This green LED would be off, no current flowing through the LED. The LED inside the optocoupler would be off, and thus no photons would be hitting the base of that phototransistor, and it would be off. It would not be conducting. So we have plus 5 volt DC applied to the input of this Schmidt trigger inverter 7414. With a high on the input, we would have a low on the output. And pin 9 of the hybrid module would be at 0 volts. Now we apply the probe from this external power supply to pin 1 of that green connector. Current flows through the green LED, turning it on, through the current limiting resistor, into the LED inside that optocoupler. Current flows through here and back to ground of this plus 24 volt DC power supply right here. Now the LED emits photons into the base of that phototransistor, driving it into saturation. And now, it being turned on, pin 1 here would be at ground potential. This is logic ground right here. And with a logic 0 on pin 1, the output of that inverter would be high, and we would see 5.08 volts on pin 9 of that hybrid module. Isn't that amazing? Now it looks complicated, but it really isn't. It's kind of like us. If you broke us down into circuits, individual circuits, we wouldn't look all that complicated either. Let's go over it again. So no plus 24 volt DC applied to pin 1. No current flow in this circuit right here. No photons emitted into the base of the phototransistor. And that phototransistor is not conducting. So we have plus 5 volts up here applied to the input of that Schmitt trigger inverter, and we have 0 volts on the output. We apply plus 24 volts here. Current flows through the green LED. The green LED illuminates. We flow through the 1.2K current limiting resistor into the LED of the optocoupler and back to ground. Photons are emitted into the base of the phototransistor. It drives that phototransistor into conduction, and now this point right here is equal to ground, logic ground right there. So we have 0 volts on the input of this inverter. And the output goes high to plus 5 volts. Nice. I like that circuit. If I was to build that hybrid module, this is how I would do it. Now there's 6 other circuits inside that hybrid module that would be just like this. I didn't show where the 5 volts and ground of the output side of the optocoupler connects to, but pin 15 on the hybrid module is plus 5 volts DC in. Ground is on pin 8, 16, 17, 18, 19, 20, and 21 of that hybrid module. There you go, folks. Isn't that fascinating? Isn't that fascinating? All right, I got to get off here and cook a little bit of dinner before it gets dark. Thank you very much for stopping by. I always appreciate it when you come over. Have a good day with your family. Enjoy the time with your family. We'll see you next time.